Hi, it's time for another math easy solution. To discuss further into calculus with parametric curves and look further into tangents and continue on the example 1 series that I've been going over. In my last video I went over part 1. Now we'll look at part 2, which looks at question B of this example. Again, recall that the example states a curve C is defined by the parametric equations x equals t squared, and we have y equals to t cubed minus 3t. And then part 1, I went over question A, which looked at finding two tangents at the point 3, 0, and I went over that, and you could check that out in my last video, and I put that video description below. So now part B, part 2, we look at question B, or part B of this example, which states, find the points on C where the tangent is horizontal or vertical. So we have to look at the horizontal or vertical tangents. Let's look at the horizontal one first. So at question B, so recall that the horizontal tangents, what this means is basically when we have the derivative or the slope dy over dx is equal to 0. In other words, if you have a curve like this, and let's say you had a point here, this is a flat tangent line like that, and that's where the slope is equal to 0. So that's the kind of tangent we want, and this is when dy over dx is equal to 0. So recall now from my earlier video that when we're dealing with parametric equations and we have x and y like that, and as a function of t, another parameter, recall that dy, so dy over dx, the derivative is equal to the ratio dy over dt, or the derivative of the y variable as a function of t divided by dx over dt, and then derivative of the x variable as a function of t. And again, I proved this in my earlier video, so make sure to check that out. Put that video description below. So if it's written like this, then what this means is if we want this equal to 0, so we want basically what we want is dy over dt is equal to 0. Just the top part is equal to 0, the whole thing goes to 0. But we also want the bottom to not equal to 0. Dx over dt to not equal to 0. And the reason we want this is because we can't have a 0 over 0. That's just going to be an undefined number. You're dividing by 0. So we want the top part to be 0 and the bottom not to equal to 0. So what we have now is if we want to look at the first part, dy over dt, first solve this and then set it equal to 0. So recall that y is t cubed minus 3t. So this is d over dt, and now this is t cubed minus 3t. So the derivative of this is just going to be, well, t cubed, bring the 3 down, and then minus a power, so 3 times t squared, minus derivative of 3t, that's just, we'll have a minus 3 like that. And then this one we can simplify as further. This is 3, take the 3 out, t squared minus 1. So this is our dy over dt. Now if we set it equal to 0, dy over dt equals 0, like this, what we end up getting is, well, this equals to 3, t squared minus 1. So what we have here is well, we want this part equaling to 0. And yeah, that's the only way we can have it equal to 0, the whole thing. So then this means we have a t squared minus 1 equals 0. Move this over, t squared equals to 1. And then we could just solve this. T is equal to, well, plus or minus square root 1. Square root 1 is just, well, 1. So this equals to plus or minus 1. And now, so then basically at t equals to plus or minus 1, we have dy over dt equals 0, but we want to make sure that dx over dt is not equal to 0, and we can check that by, well, dx over dt, this equals to d over dt, and now we plug in, well, the x equation, that's t squared, and that is, well, t squared like this. The derivative is just 2t. Yeah, so the derivative is just 2t, and now if we plug in plus or minus 1, so we'll put this like this, and what we end up getting is a dx over dt is equal to 2 times plus or minus 1, that just equals to plus or minus 2, which is, well, not equal to 0. So we've concluded, yeah, that's just not equal to 0, so then this is where the the horizontal tangent lies. So thus what we have is thus horizontal tangent, tangent like that, at, and this is at t is equal to plus or minus 1. And this is actually two tangents here because we have plus or minus 1. So what we have now, we want to solve for the x and y variables. So the x and y variables are x equals 2. Well, x is just equal to t squared. So we could plus or minus 1 inside. This equals 2 plus or minus 1 squared. And then whatever is inside is always going to be positive. And 1 squared is just 1. So we have it at this point. But again, remember, this is twice. Because we have a plus 1, it becomes 1, and then minus 1 also becomes 1. So we have so we have x variable happening twice at this t is plus 1 or minus 1. So now what we want is the y. This equals to, well, again, t cubed minus 3t. This equals to, well, plus or minus 1 cubed minus 3 times plus or minus 1 like that. And now this one's cubed, so then if we have a negative, it stays negative. And then what we have here, this is plus or minus 1 like that. So what this equals to is, well, this is still going to be plus or minus 1. 1 cubed is just 1. So we have plus or minus 1, and now we have a minus plus or minus. So then remember, if it's a plus, it becomes minus. If it's a minus, it becomes a plus. So what that means is this gets flipped. Now we have a minus. So if it's a plus, becomes a minus, then if it's a minus, becomes a positive. So we have a minus plus 3, and this will make sense as I get to it. So now we have this. Just wanted to show you that. It's pretty cool. So now what we have is this equals 2. We could either do so we could do plus 1, and then if it's a plus 1, then we have a minus 3. Minus 3, this equals to negative 2. Or if it's a minus, we have a plus. So minus 1, this is just a cool way of putting it all into one formula. So now we have a minus plus 3, and this equals to, well, plus 2. So now this means we have, well, minus 2 or plus 2. This is basically y is equal to plus or minus 2, and we have x is 1 on both times. So whichever value plus or minus 1 we have. So what this means is we have horizontal tangents at the points 1. This is at the first point is at 1, and then 2, and then we also have at 1 and negative 2. So these are horizontal tangents like that at these 2 points like that. And now what we want is the vertical tangent. So what we want, so vertical tangents are when we have just a vertical line. Vertical tangents are when we want is when the slope dy over dx is a vertical line. In other words, it's approaching infinity. So we have a curve. Let's say we had a curve like this. Let me just see what we could draw like this. Then this curve is going upwards to infinity, like that. So it's an infinite slope. So what this means is, well, dy over dx, if this equals to dy over dt over, for differential equations, dx over dt, like this means that the bottom one is approaching 0. So in other words, dx over dt is equals to 0. So if it equals to 0, then you're dividing by 0. In other words, you're going to infinity. And again, we want this one not equaling 0, so we don't have a 0 over 0 scenario. So we can't have a dy over dt equals 0. So this is what we want. So we want this scenario where the bottom is 0, so it goes to infinity. Dy over dx goes to infinity, and then dy over dt just can't equal to 0. Otherwise, we'll have a 0 over 0, undefined, etc. So now that we have this, let's look at dx over dt. So recall dx over dt is equal to, well, we could just go up here. Dx over dt is just 2t, derivative of t squared. So this equals to 2t, and now if we plug in, or not plug in, we set it equal to 0. So this equals 0. In other words, t is equal to 0. So t is equal to 0, this one's a simple one, and now we have to check if dy over dt is equal to 0. dy over dt, this equals 2, and recall that dy over dt is equal to, well, 3 times t squared minus 1. So we have 3, now we have t squared minus 1, and now if we plug in t equals to 0, like that, inside we get 3, 0 minus 1, this just becomes negative 3, which is not equal to 0. So this is a check mark for us, so we just stick with the t0. Yeah, so what we have is thus, thus vertical tangent at basically t is equal to 0. And then we could solve for the x and y. X is equal to, well, t squared. And then if we plug in 0, that's just 0. 0 squared. So x is 0. And now for the y, we have, let's write it here actually. So y is equal to, t cubed minus 3t. So then plug in 0, we have, well, 0 minus 0 is 0. So in other words, we have that the point 0, 0 at the origin. Like that, that's a vertical tangent. And now if we were to graph this, so if we had, let's say, a graph like this, this is the x, this is the y, so we have a vertical tangent at 0, 0, that's at this point here, 0, 0, so basically if we draw this across like an arrow, like that, it's hard to see, this is our vertical tangent there. So it's just on the axis itself. So it's a vertical tangent like that, and then we know that at the point 1, and then it goes up to 2, let's say it's somewhere here, and then let's say 2 is over here. Actually, I'll move this down further just to make it a bit even. So then let's say 2 is over here, I'm negative 2. So this is positive 2, negative 2, and then we have it at this point at 1 and negative 2. This is at 1, negative 2, and we have a horizontal line like that, a horizontal tangent, and then also at here at this 1, positive 2, and we have a horizontal tangent like that. And also recall from my earlier video, if we go to, let's say this is 2, this is 3 on part 1 or question A, I showed that we had 2 tangents that crisscross like this at this point here. And eventually we'll show you how the graph looks like. And this is from A or basically part 1. I'll just put a line like this, part 1. So make sure to watch that where I showed that there was 2 tangents there, right, this neater. And yeah, as you can see, this graph is it's showing a bit more of how it looks like, and eventually, we'll graph the whole thing. It will look pretty cool. Anyways, that's all for today. Hopefully you'll learn from this pretty interesting video on just graphing parametric curves, and stay tuned for the later parts, which I will go over and show you how you can sketch the graph just by calculus. Anyways, that's all for today. Hopefully you'll learn. Like always, you can download these exact notes in the link below. Thanks for watching, and stay tuned for another math easy solution.